Hello everyone, so today we'll be solving the problem number 395, longest substring with at least k repeating characters. So the problem says given a string s and an integer k, return the length of the longest substring of s such that the frequency of each character in this substring is greater than or equal to k. If no such substring exists, return k. So the very first brute force intuitive method that comes to mind is we can use two pointers to find every substring and then take a character map of every substring and look for the number of values and look for the character count of the frequencies in that map. And once we have the character, so the maximum frequency of character that we can have, we will have that in the map, and that would be our maximum length for the substring that we have. So initially we have only one character, then we expand our window for the substrings. So we have two characters now, both has a count of 1. Again we can increase this to third, then we'll have our sub characters, we'll have characters count 2. Still we have two characters, so this is a valid substring. Again we will increase this, again this will increase this to next substring, so we'll increase our b count by 2, and at the end, once we have reached the maximum substring over here, this is the maximum values of characters that we can have, and the maximum length of substrings is this length, which is r minus l plus 1. And we cannot increase, if we increase, let's say if we increase the window to here, then we have a character c, though, but we are not supposed to have more than k characters into our substring, so this would become an invalid substring, so we don't want that. So this is the brute force way of solving this problem, and this is the maximum length, and we can store that into our one variable answer, and that will give us the maximum length among the all the substrings that we have computed so far. And as we can see, this brute force time complexity would be O of n cube, because we need two passes to create the substring and one pass to create this hash map or ours. So the real question starts from now, that can we do better than this? Can we do better than the O of n cube? So the answer is yes, we can definitely do better than the brute force. We can use divide and conquer method. We can use divide and conquer algorithm to solve our problem. So what we can do is, we can so here is what we can do. We can initially, so let's say if we have our substring, we have our string like this, b a c c c a and d e f. So the maximum substring that we can see over here without repeating longest substring that we can have is this a c c c a, right? And because if we have k is equals to 2, so the longest substring such that the frequency of each characters is not is greater than equals to k would be this. And so what we can do is we can create one initial frequency map of all the characters with their frequencies, and then we can split on the basis of minimum count of the character that we have. So that, and we will recursively then solve the sub problems for each splitted sub problem that we'll have in the split wise. So here is how we can split this. So we'll split it on the character count of a, suppose. So this problem would become something like this. So now we have b, c, 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 and d, e, and f. So the maximum length that we can have in this region would be, the length of b is maximum is 1, the maximum length of this substring is 3, and again by splitting these 3 into individual sub problems, we can have their individual length as 1 1 1, and we'll take the maximum of all these 3. We can take the maximum of all these individual problems, and that way we can have the maximum length of the longest substring that we supposed to need to have. So this is how we can write out this problem using divide and conquer. So we'll create our hash map for characters in s, count of character, for characters and their count in the count items. If the count is less than k, then we need to find all the substrings and their lengths. So what we'll do is we'll take substring and we'll split it on the characters of the hash map. So now we need to find the length of each substring that we have. And we will append this substrings into the empty array of sublength that we created. And once we have all these, we want to return the maximum length of the array sublength. And once we, this is our base case, that when we have no characters left in the recursion, then we need to return the minimum length, which is 1. So let's run our problem. Okay, so we are given an input of 3, that we need to have maximum 3 characters. So this is the longest substring having 3 characters, B, A and C. And if we see, if we need 2 characters, then the longest substring length we can have is 5, right, which I explained earlier. So let's submit our code and see how fast it runs. Okay, so it's pretty fast and it is amazing. So that's how we can solve this problem. Thank you.